All right, hello everyone. Welcome to my channel. This is an educational channel focused on bringing to light uh, some unsung heroes of my life who have done great work in putting together mainly theories of everything, all-encompassing theories that I think could help out a lot of people if they knew about them. These are people who pretty much never got any recognition, at least during their lifetimes or while they were writing. And today is video number 202 on the reciprocal system of theory from Dewey B. Larson. Mr. Larson was born back in 1898 and began having some epiphanies about his reciprocal system way back in about 1930. It took him about 25 years to develop his ideas and put out his fundamental postulates in the late 1950s, and then began writing books through primarily a process of deduction from his postulates. Okay, if these postulates are what I say they are, then they lead directly to certain results. If this, then that, and then if this, then that. And I did about 15 videos earlier covering his a talk that he gave called the deductive development of the reciprocal system. So if you want to hear how he did that deduction one step at a time, check out those videos. Now, the basic idea behind the reciprocal system is that we live in a universe of motion. And motion is a relationship between space and time. So space and time are the contents of this universe, not the containers of this universe, but the contents of the universe. And they have a generalized reciprocal relationship. Motion is a fraction that has either time or space as the numerator and either space or time as the denominator. And that can be a little bit more complicated because time and space both are coordinate, meaning that they have three or maybe even more dimensions, x, y, z coordinates. So we recognize that as in space, that space is three-dimensional or more. Time also has three or more dimensions. Also, space and time both have their scalar clock aspects. Clock time, the progression of time. Time is always getting later and later and later, the flow of time. In the same way, space is also scalar and progressing. Things are getting farther and farther and farther apart. That is the progression or the flow of space. And then time and space also have come in only discrete units. There is a minimum unit of time and a minimum unit of space, below which there is no time and no space. So that kind of creates a few boundaries in the universe of motion, where you have less than 1 unit of space, you have a world of time only. And when you have less than 1 unit of time, you have a world of space only. And it also sets up a middle boundary of what Larson calls unit speed, because if you have exactly 1 unit of space in 1 unit of time, you have the speed of light. And so the speed of light is the boundary between two separate universes, which Larson calls the material sector, that is the slower than speed of light universe, and the cosmic sector, which is the faster than speed of light universe. Now we know basically from measurements and observations of scientists over thousands of years, we know a lot of things about the material sector. We know very little about the cosmic sector, but because of the reciprocal relationship between space and time, we can extrapolate over to the cosmic sector to understand it much better. Our information from the material sector, all we have to do is reverse the roles of space and time. And so, for example, in the material sector, we have coordinate space, three-dimensional space, and clock time, progressing time. This is what we're accustomed to. We live in this three-dimensional space, and the clock is always moving later and later and later. But in the cosmic sector, we have three dimensions of time, and we have progressing space. Space is always getting farther and farther and farther apart. So this is a reversal. So we kind of have to get our minds around what that actually means to be able to start to understand the cosmic sector. And now another way to look at that is in terms of atoms and molecules and even particles. These are all combinations of motions. So you basically have four different kinds of motion. You have a translational motion, you have a vibrational motion, you have a rotational motion, and you have a rotational vibration. And they can be in multi-dimensions as well. Now, the basis of all matter is going to be the photon. The model for the photon is in dispute. According to Larson, the photon is really a combination of your translational motion and a vibrational motion in a perpendicular dimension. You combine the two and you get a sine wave, or simple harmonic motion. Now, some of Larson's followers have come along and said that actually the simple harmonic motion or the sine wave comes from a combination of two rotations, birotation. And that was shown by Leonard Euler, the mathematician, as what he called the epsilon function, I believe. So that's two different interpretations of what the photon is. Regardless, the photon is at the core of the atom, and so then once you have a photon, then you can rotate it in various ways to create matter. So for Larson, matter is made out of has three number notation system. So the first number is your primary two-dimensional rotation. The second number is your secondary two-dimensional rotation. And then the third number is your one-dimensional rotation. And that's how he built up the periodic table. Now here in what we're looking at today, we're looking at his 1979 book that is called Nothing But Motion, which is primarily on atomic physics. And chapter 15, which is called Cosmic Ray Decay. And so he's looking really at the nature of cosmic atoms. And so again, what we have is we have a reversal of the roles of space and time. And then when we're looking at cosmic ray decay is a process where a cosmic atom, for whatever reason, enters the material sector. What happens when a cosmic atom enters into the material sector? This usually happens as a result of an exploding star or galaxy. And that happens also into when a material star blows up, it blows up into the cosmic sector. And so when a cosmic star blows up, it blows up into the material sector. But since a cosmic atom, when blowing up into the material sector, is not that's not its normal environment. And so it begins to immediately decay or become radioactive or unstable. And so the process of decay of the cosmic atom is what he's detailing here. This is generally the realm in legacy science of what they call mesons. Okay, we're going to let Larson speak here and go. We're in the middle of chapter 15 on cosmic ray decay. Hopefully, he will explain it. Um, The general nature of the cosmic ray decay process, as described in the foregoing paragraphs, was clear from the start of the investigation of the role of the cosmic rays in the theoretical universe of the reciprocal system. It was therefore evident that the ejections during this decay process must consist of positive rotational displacement in order that the cosmic atoms would be modified in the direction of greater stability in the material environment and ultimately built up to the level where conversion is possible. In the first edition, these ejections were discussed in terms of neutrons and neutron equivalents, although it was noted that in the terrestrial environment at least, they must be massless. Transfer of mass in these events is impossible, as the cosmic atoms have no actual mass. The mass indicated by their behavior in the observed reactions is merely the mass equivalent of the cosmic mass that these atoms of the cosmic elements actually do possess. What these atoms must eject is positive magnetic rotational displacement, and this can only take place. Now, when he says, sorry to interrupt, but when he says positive magnetic rotational displacement, magnetic for him is really a synonym for two-dimensional. When he says electric, he's talking about one-dimensional. So when he says it must eject positive magnetic rotational displacement, positive two-dimensional rotations, those are those first two numbers of his notation. One is the primary two-dimensional rotation, one is the secondary two-dimensional rotation. So he's referring to both of those things. What these atoms must eject is positive magnetic rotational displacement, and this can only take place through the medium of massless particles. The conclusion reached in the earlier study was that in these ejection events, the carrier particles must be pairs of neutrinos and positrons, jointly equivalent to neutrons rotationally, but massless, rather than the neutrons of the observed type. The more recent finding that the neutron exists in a massless form now resolves this difficulty, as it is now evident that the ejected particles are massless neutrons. The progress that has been made in both the observational and theoretical fields has also enabled defining the decay path more accurately and in more detail than was possible in the first edition. Inasmuch as all features of the cosmic sector of the universe are identical with the corresponding features of the material sector, except that space and time are interchanged, the matter accelerated to high speeds by cosmic explosions of astronomical magnitude includes all of the components of cosmic matter, subatomic particles, and atoms of all of the elements. But in order to be accelerated all the way to unity in 3 dimensions, a particle must offer a full unit of resistance in all 3 dimensions. Consequently, the only particles that are able to accelerate up to the escape speeds are the double rotating systems, the atoms. The unit particle in the interchange between cosmic and material sectors is the atom of unit atomic number, the mass 2 isotope of hydrogen, which is called deuterium. The mass 1 isotope of hydrogen does not qualify as a full-sized unit, but it lacks only the equivalent of a cosmic massless neutron, and this can be provided by ejection of a massless neutron of the material type. When subjected to a powerful explosive acceleration, the hydrogen 1 atom therefore ejects such a particle and assumes the hydrogen 2 status, or deuterium. The subatomic particles are not capable of being accelerated to the escape speed. They are all either inherently massless or easily separated into massless components, and when they reach their limiting speeds, they take the massless forms and thereby terminate the acceleration. The total absence of subatomic particles in the cosmic rays that results from this inability to reach the escape speed is not currently recognized because the singly charged particles are mistakenly identified as protons, and the cosmic atoms in the decay sequence, mesons in the conventional terminology, are accorded a somewhat indefinite kind of subatomic status. But the absence of electrons is a conspicuous and puzzling feature of the cosmic ray phenomena, and it imposes some severe constraints on theories which try to account for the origin of the rays. An effect so gross as to exclude, this is a quote from T.M. Donahue, an effect so gross as to exclude completely high-energy electrons from the spectrum at the Earth should, it would seem, be accounted for unambiguously by any successful theory for the origin of the cosmic radiation, end quote. The unambiguous explanation is now available. No subatomic particles are present in the original cosmic rays because these particles are not capable of accelerating to the high inverse speeds necessary for entry into the material sector. The cosmic property of the inverse mass is observed in the material sector as a mass of inverse magnitude, where a material atom has a mass of Z units on the atomic number scale. The corresponding cosmic atom has an inverse mass of Z units, which is observed in the material sector as if it were a mass of 1 over Z units. The masses of the particles with which we are now concerned are conventionally expressed in terms of million electron volts. One atomic mass unit is equivalent to 931.152 million electron volts. The atomic number equivalent is twice this amount, or 1,862.30 mega electron volts. The primary rotational mass of an element of atomic number Z is then 1,862.3 Z million electron volts. And that of a cosmic element of atomic number Z is 1,862.3 over Z million electron volts, where the atomic mass M is expressed in terms of atomic weight. This becomes 3,724.6 over M mega electron volts. As matters now stand, neither the theoretical calculations nor the observations of the masses of the cosmic elements above hydrogen in the cosmic atomic series are sufficiently accurate to justify taking the secondary mass into consideration. The theoretical discussion of the masses of these elements will therefore be confined to the primary mass only, disregarding the small modification due to the secondary mass effect. Now, remember, the secondary mass effect has to do with subatomic particles, charges, and the like. The primary mass is due to the matter. So, for the same reasons, both the calculated and observed values in the comparisons that follow will be stated in terms of the nearest whole number of mega electron volts. An exception has been made in the case of hydrogen because the secondary mass of this element under normal conditions is relatively large, and the probability that it will be altered by changes in environmental conditions is relatively small. Since the mass of a material deuterium atom is 1.007405 on the atomic number scale, the mass of a cosmic deuterium atom is the reciprocal of this figure, or 0.99265 units. This is equivalent to 1,848.6 megavolts. At this point, it will be necessary to recognize that the combinations of motions that constitute the atoms of the elements, both material and cosmic, are capable of acquiring additional motion components of a different kind, each unit of which alters the mass of the atom by 1 atomic weight unit. It will be convenient to defer the detailed consideration of this new type of motion, which we will call a gravitational charge, until we are ready to discuss the entire class of motions to which it belongs. But for present purposes, we need to note that each material element of atomic number Z exists in a number of different forms, or isotopes, each of which has an atomic weight of 2Z plus G, where G is the number of gravitational charges. The normal mass of the corresponding cosmic isotopes is the reciprocal of 2Z plus G. But when the cosmic atoms enter the material environment, they are able to add gravitational charges of the material type to the cosmic combinations of motions, including the gravitational charges of the cosmic type, if any. Each such material type charge adds 1 atomic weight unit, or 931.15 megavolts, mega electron volts, to the isotopic mass of the cosmic atom. Okay, I think we're going to stop there. For now, we will go on as he kind of tries to demonstrate that his system is able to come up with accurate answers about the origination of mesons and their megavolts, mega electron volts. Okay, well, have a great day. We'll take over tomorrow. See you then.